Okay, so this is page 11 of your worksheet on 10.2, arithmetic sequence. So we're actually going to use the equation they gave us in 10.1 on this worksheet. Okay, so you have the how to find the common difference, where you just subtract, and then they give you this nth term, an equation to find the nth term of a sequence. And in 10.1 we really didn't use this equation, but we're going to this time. So let's look at example 1. It says to find the 13th term of the arithmetic sequence when a sub 1 is 21. That's your first term in the sequence. And d is negative 6. So that's the difference between each term in the sequence. Okay, so I need to know what n is to find the nth term. What is n in this problem? 13, right. It tells you it's the 13th term. Okay, so now I just need to substitute values in to my equation. So I'm going to find a sub 13. Instead of an n now, I'm telling which number I'm going to find. I'm finding the 13th term. So your equation is going to equal a sub 1, which is 21, plus n, which is 13, minus 1, times the difference, or d, which is negative 6. And now we just need to do the order of operations. So I'm going to combine my parentheses. 13 minus 1, that's going to be 12, times negative 6. Okay, that's negative 72. And 21 plus negative 72 is negative 51. So that is your 13th term in that sequence. Okay. Any questions? Okay, let's look at the second example. Write an equation for the nth term of the arithmetic sequence negative 14, negative 5, 4, 13, and it goes on. And so we are going to write a generic equation that would fit this sequence. So you could find any number that you wanted to in the sequence. So we're going to use the a sub n equation, but the n is going to stay a variable, because this is going to fit for any number in the sequence. So this a sub n, that n right there, that's going to stay in the equation. I'm going to replace a sub 1 with the first term. Negative 14 is the first term in the sequence. And then I'm going to replace d with the difference. So I need to find out how much it's increasing or decreasing by. So 13 minus 4 is going to be 9. So that's going to be your d. A sub 1 is negative 14. That's your first number in the sequence. Okay, so let's substitute those values in. Negative 14 plus n minus 1 times 9. And I want to simplify it as much as I can. So I'm going to distribute the 9. And then combine my like terms. So your final equation would be a sub n equals 9n minus 23. And that is the equation that you would use to get whatever term you wanted in this sequence. Any questions? Okay, let's look on the other side, page 12 of your worksheet. Arithmetic series. A shorthand notation for representing a series makes use of the Greek letter sigma. Sigma notation for the series 6 plus 12 plus 18 plus 24 plus 30 is the sigma with n equals 1 on the bottom, the number 5 on the top, and then it gives you the function 6n. So what this means is The bottom number tells you what number you start with. So this is saying that you're starting with the first number in the series. The way you get the first number in the series is by substituting this 1 in for the n. So your a sub 1 is going to be 6. Okay, the number on top tells you what you want to stop at. So I'm going to find the sum of all the terms in this series from the first one to the fifth one, is what that's saying. So to get your a sub n, I'm going to take this top number and substitute it in. So a sub n is going to be 30. Okay, and then this is just your function out here, right? Now they give us two equations to use to find the sum. It just depends on what information you get in the problem. So we have to evaluate what they give us in the problem with the two equations that we have and then decide which one to use. So the first one, these are both in the box at the top of your paper. This S sub n means you're going to find the sum. That's what that stands for. The n's is the number in the series, like what the order is, okay, which one is it? And then a sub 1 is the first number in the series, and d is the difference. So in this case right here, I don't know what the d is, right? I know a sub 1 and a sub n. So I wouldn't be able to use this to get the sum because I don't know what d is. And I need to find n. So let me tell you how to find the n. And this is going to work for any sigma notation. It doesn't matter. In this case, when you start with 1, you're going to wind up with n is 5. So anytime this number on the bottom is 1, your n is always whatever the number is on the top. But let me show you how to do it no matter what this number in the bottom is. You're going to take the top number, subtract the bottom number, and then add 1 back to it. And the reason you add 1 back to it is so you'll be including that number. Because when you just take 5 minus whatever that is, you're not counting where you start. Okay, so that's why you're going to wind up with 5 for n. Okay, so your second equation that you could use is S sub n equals n over 2 times a sub 1 plus a sub n. This one's a little bit shorter, and I like using that one better because it's a little easier. Don't have so many things to plug in. So anytime we can use this one, that's my preferred method. And I have the a sub 1, the a sub n, and n. So I could find the sum from the first number to the fifth number just by substituting in the values and solving.